This is Calculus, topic 1.3, number 27. Number 27, we want to find values for this for h of -3, h of -2, h of -1, h of 0, h of 1, h of 2, and h of 3. Okay, so we're going to put this expression in the calculator. Okay, and let's see here. We're going to go into our y equals mode, and we're going to type in 1.01, open parentheses, 2.02, and then our caret, raise the power, and then the -4x, we're going to put that in its own parentheses as well. So parentheses, -4x, close parenthesis. And then we're going to close the last parenthesis for the base, 2.2, so closing it there. Okay, now I'm going to hit trace. Okay, and the graph is up there, you just can't see it very well. But I want to put in -3, so type, let's see here, -3, and it appears there, and then hit enter. And that number is 4661.63. Okay, then I'll type -2 next. Here, -2, hit enter. And now I have an answer of 279.98. -1, enter. And I have an answer of 16.80. I'll round that 1 up to a 2. 0, enter. I get 1.01. And now I put 1 in. And I get a 0.06, and put in a 2 now, 2, enter, and I gotta stretch my decimals out a little bit more, 0.0036, and then finally 3, I get, that -4 there, the e to the -4 means I need to push the decimal back 4 times, which will add 3 zeros, so 3 zeros, 1, 2, 3, and then the number 218, or 219, I'll round it up to a 9. So 219. Okay, now here we want to convert this into an exponential function. So the general form of an exponential function is y equals a b to the x. Alright, so we're going to put, let's see, 1 for the x for the input and 1.2 for the y. So 1.2 equals a, b to the first power. And now what I'm doing here is I'm solving for my a by putting in this for x and this for y. So b to the first power is still b, divide by b, and we'll get that a equals 1.2 over b. Okay. Alright, furthermore, we're going to do this again. We're going to put in the x and y from these two right here, and also the new a. So y is going to be 1.08 equals a, which is now 1.2 over b, and then b to the x power, which is 3. Okay, now when I simplify the b and the b to the third power, this will divide and I'll get b squared, so this will be 1.2 b squared. Then let's divide everything by 1.2. So let's go back to here. So 0.108 divided by 1.2 will be 0.09, and that equals b squared. Okay, from there I'm going to take the square root of both sides, and I'll have b equals, let's see, I think 0.3 will be the answer. Now, with 0.3 being the answer for b, I can take this 0.3 and put it in here and solve for the rest of my a. So this will be 1.2 divided by 0.3 equals a. And so 1.2 divided by 0.3, and we get 4. Okay, therefore, our equation will be y equals 4 for a, 0.3 for b, to the x power. Alright, let's try it again. Number 62. Okay, once again, we're going to have a form that we'll use the general form y equals ab to the x power for the negative 1 and 2, and also again y equals ab to the x power for the 3 and the 1. So we'll put the 2 here for y, and we'll put the negative 1 in here for the b, for the x, should I say. Alright, with the negative 1, when I simplify that b will become a denominator, so this will be 2 equals a over b. Then I can multiply both sides by b, and I'll get 2b equals a. And now a is solved. Now let's go over here and put in our 1 for the y, our 2b for the a, and our 3 for the x. Okay, now from there, we're going to combine the b and the b to the third, which will give us 2b to the fourth. Divide everything by 2, and we'll get 1/2 equals b to the fourth power. Okay, now I want to take the fourth root of both sides. This will give me the fourth root of 1/2 equals b. Okay, and that's a pretty lousy number, but we'll live with it. Okay, it's about 0.5 under the cube root. And so a ends up being 2 times the fourth root of 1/2. Okay, so now we have our a and our b. So now we can say x equals a, which is 2, the fourth root of 1/2, and a b, which is the fourth root of 1/2 all raised to the x. And that's our final answer. Okay, we have bacteria that starts at 1,000 and doubles in size every 3 hours. Find the exponential model and predict the number of bacteria in 2 days. Okay, well, in order to create models, we need points. 2 points. Okay, the output of this model is going to be bacteria. So instead of using y equals, we're going to use b equals for bacteria. That'll be the output. You still have the a and the b. Now the input, even though we're outputting bacteria, we're doing it for time, 3 hours in particular. So I'm going to use a t for time. So I'm going to write another one over here. Okay, and I'm going to solve for a here, but I need points. So the points, I know my output is going to be bacteria, so that'll be 1,000. And it's going to double in size every 3 hours, so I know I'm going from 1,000 to 2,000 of them. Okay, that's my output. Now, furthermore, time. Since we're starting at 1,000, the time is 0. And 3 hours later, that's the time now, we'll have 2,000. So that's our points for our model. So 1,000 goes in for the b, and for the t we have 0. Okay, again we're solving for a. So b to the 0 is going to be 1. So that's a times 1, which simply means that a is 1,000. Okay, we'll go here. The b is the 2,000. The a is the 1,000. Bad looking 1,000. And b is to the third power. So when I divide everything by 1,000, I'll get a 2 over here and a b to the third power. From there, I'll take the cube root of both sides, and this gives me b equals the cube root of 2. Alright, so finally, what I have is bacteria equals a, which is 1,000, and b, which is the cube root of 2, all raised to the time. And this is a function of time. So, for 2 days of bacteria growth, how many hours is that? That's 48 hours. So there'll be b with 48 hours of time put in. We'll have 1,000 cube root of 2, all to the 48th power. All right, let's put that in. Let's go to, let's clear that up. All right, 1,000. I'll open up the parenthesis and I'll put in the cube root of 2. To find the cube root, you type in math and go to number 4. There's the cube root of 2. And I'll close the 2. And then I want to raise all of that to the 48th power. So to the 48th power. And then we're going to close the root with a parenthesis. Let's see, make sure that's what I want. I think so. And there we go. The bacteria will now be 655360000. So that's 65 million bacteria in 48 hours.